Okay, we'll do another rational zero problem here. This one, we have a polynomial of degree 4, but same kind of idea. They tell us that it has at least one rational zero. We want to use that to find all the rational zeros. So we'll copy our polynomial down. In this case, it's f of x equals 3x to the 4th minus 17x cubed plus 8x squared plus 11x minus 5. The big difference here is we're kind of going to have to do the synthetic division step twice, because instead of having degree 3, you do it once, you get a quadratic, which you can deal with more easily. Here we have a quartic, so we have to kind of do it twice to get it down to a quadratic. So this has at least one rational zero. Okay, let's figure out what that rational zero is, or what one of them is at least. And again, we want to look at the constant term and the leading coefficient. Okay, so our possibilities are going to be factors of 5 divided by factors of 3. So plus or minus 1 or plus or minus 5 over plus or minus 1 or plus or minus 3. So not too many possibilities to deal with. Okay, so that's plus or minus 1, plus or minus 5. Okay, plus or minus 1/3, and plus or minus 5/3. Okay, so a lot fewer in terms of the number of possible zeros to deal with. From there, we'll set up our synthetic division. So 3, negative 17, 8, 11, and negative 5. Remember, we want to kind of use whatever number comes from this list, that when we multiply it by 3 and then add it to negative 17 gets us closest to 0. So that's going to be 5. Okay, this isn't a guarantee that 5 works. It just means that 5 is kind of a good place to start. So we bring our 3 down. Okay, 3 times 5 is going to give us 15. 15 minus 7 gives us negative 2. Negative 2 times 5 gives us negative 10. 8 minus 10 gives us negative 2. Okay, 5 times negative 2 gives us negative 10. 11 minus 10 gives us 1. 5 times 1 gives us 5. Minus 5 gives us 0. Okay, so that technique really does cut down the time usually. So we know that 5 is a rational zero, and we know that the quotient, when we divide that in, is 3x cubed minus 2x squared minus 2x plus 1. Okay, so we can start by rewriting f of x as x minus 5 and 3x cubed minus 2x squared minus 2x plus 1. Okay, so from there, our plan of attack is to look at this and again apply the rational zero theorem. Okay, so in this case, it's going to come from factors of 1 and 3. Okay, so that's going to be plus or minus 1, okay, over plus or minus 1 or plus or minus 3. Okay, so our possibilities are plus or minus 1 and plus or minus 1/3. So even fewer options. Again, same kind of idea. Now we have 3, negative 2, and 1. Okay, and let's see. What number is there that when we multiply it by 3 and add it to negative 2 gets us closest to 0? That's, again, pretty clearly here going to be that 1. Okay, so let's try 1. We bring 3 down. 3 times 1 gives us 3. 3 minus 2 gives us 1. 1 times 1 gives us 1. 1 minus 2 gives us negative 1. Negative 1 times 1 gives us negative 1. 1 minus 1 gives us 0. Okay, so we're 3 for 3 on that technique. It is pretty useful. So we can rewrite it again. Now we know that 1 is a rational 0. Okay, so f of x equals x minus 1, x minus 5, and now we have a quadratic. So 3x squared, okay, plus x minus 1. Okay, and now we just want to find the zeros of this quadratic. You can use the quadratic formula, opposite of b, so -1 plus or minus the square root of b squared, so that's just 1, minus 4ac, but of course it's going to be plus because we have this negative sign here, so this is plus 12, all over 2a, so this is all over 6. Okay, so we have -1 plus or minus the square root of 13 all over 6. Okay, so we could, if we wanted to, this problem doesn't ask us for linear factorization, but same idea here. We use that 3 as our leading coefficient, and then we have x minus 1, we have x minus 5, we have x plus, let's see, and we have x that. Okay, so those are our 4 linear factors. Okay, but again, they don't want that on Alex. All they want is you to list zeros. So we go to list our zeros. We'll start with our rational zeros. So we have 1. Okay, we have, oops, we have, why that's not working. There we go. 1. We have 5. We have, and this is pretty useful because it gives us a plus or minus sign there. So we'll have -1, oops, -1 plus or minus the square root of 13 all over 6. And those are our answers.